Modulus Inequalities.
Hello everyone! In this video, I am going to show you how to solve modulus inequalities where modulus f of x is greater than or less than g of x. In my previous video, I have shown you how to solve modulus inequalities where modulus f of x is greater than or less than a constant k. Have you watched it? If not, then you can click on the link on top here to watch the video before you continue in this video. You can also find the link in the description. If this is your first time here, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss anything. If you find that this video is useful, hit the like button below. So, let's start the lesson right now. Today, in this video, I am going to talk about how to solve inequality of modulus f of x greater than or less than g of x algebraically or graphically. Now we start from solving the modulus algebraically. And as we know that if modulus f of x is less than g of x, then it is same as f of x is greater than negative g of x, and at the same time f of x is less than positive g of x. If we are not able to solve this inequality directly, then we need to separate this into two. First one is f of x is greater than negative g of x, and at the same time f of x also less than positive g of x. And if modulus f of x is greater than g of x, then this means that f of x is less than negative g of x, or f of x is greater than g of x. Now, let's try to solve this modulus inequality by using algebra. So, the modulus of x minus 2 greater than 1 over x. When we solve this modulus by using algebra, so first thing we need to clear the modulus sign. So, because of this one is greater than, so means when taken away the modulus sign, it becomes x minus 2 less than or equal to negative 1 over x, or x minus 2 greater than positive 1 over x. Now I'm going to solve this inequality separately. So first I shift the term to the left so that it is equal to 0 on the right. Now I try to combine all the terms on the left becomes a single fraction. Now I factorize the quadratic, becomes x minus 1 squared divided by x less than equal to 0. Now to find the set of value of x in this inequality, I am going to make use of a number line and label with the critical point, where the critical points are the value of x, where x minus 1 becomes 0 and x 0. So that is when x is 0 and x is equal to 1. Now I'm going to test x minus 1 squared. Since it is squared, so x minus 1 squared, the value is positive in all the region here. Now for x is negative when x is less than 0, positive when greater than 0. So now we combine in order to find the final set of value of x. So for x less than 0, positive times negative, it is negative. When 0 to 1, positive, positive, we will get positive. And when x greater than 1, positive, positive, we will get positive. Since the inequality is less than, so we are going to take the value of x where it is negative here. So the set of value of x in this inequality is x less than 0 but not included 0 because x is the denominator and we know that denominator will never take the 0. Now we go to the next inequality. First, we shift the term to the left. Then we try to simplify all the terms on the left becomes a single fraction. Now when we try to factorize the quadratic, we found that we are not able to do the factorization. So what we need to do is we need to carry out completing the square. So when we carry out the completing the square for x squared minus 2x, we found that it is x minus 1 squared minus 1 minus 1. This is the completing the square from x squared minus 2x. Then after that we simplify becomes x minus 1 squared minus 2 over x greater than 0. Same as just now. Now we need to mark the number line with the value of x where the numerator is equal to 0 and denominator is equal to 0. So first, when x minus 1 squared minus 2 is equal to 0, so now we try to find the values of x. So we found that the value of x is equal to 1 plus and minus square root of 2. Now from the calculator, we found that 1 minus square root of 2 is approximate to negative 0.4 and 1 plus square root of 2 is approximate to positive 2.4. So now when we mark the number line, so on the left hand side is 1 minus square root of 2, on the right hand side is 0, then followed by 1 plus square root of 2. Now we are going to test the value of x minus 1 squared minus 2 and x in each section. So first we test x minus 1 squared minus 2. So when x is less than 1, minus square root of 2 means when x is less than negative 0.4. So we found that this is positive. And when x is from 1 minus square root of 2 up to 0, we found that this is a negative value. Same as 0 up to 1 plus square root of 2, it is negative. But when x is greater than 1 plus square root of 2, it is positive. Now we continue to x. When x is less than 0, x is negative. When x is greater than 0, x is positive. Now we combine these two answers to find the final answer. Now for the first region, positive, negative, 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 positive, and negative, positive, negative, positive, positive, positive. So since the inequality is greater than 0, so we are going to take the positive region. Therefore, the set of value of x which is greater than 0 is x is greater than 1 minus square root of 2 and less than 0, and also when x is greater than 1 plus square root of 2. Now we need to combine this set of value of x number 1 and number 2 by using the conjunction OR. So first we mark the important point in this set of value of x on number line. First is 1 minus square root of 2 followed by 0 followed by 1 plus square root of 2. So from the first set of value of x, when x is less than 0, not included 0, it is number 1. Then number 2, x is from 1 minus square root of 2 up to 0, and x is greater than 1 plus square root of 2. Since we combine by using the conjunction OR, means we are going to take the region where the value of x is covered by the arrow line. So therefore, in this diagram, that is x less than 0, not included 0, and x greater than 1 plus square root of 2 and included square root of 2. So therefore, we can write the final solution as where x is less than 0 and also where x is greater than 1 plus square root of 2 included the point 1 plus square root of 2. Now the same modulus inequality. Now I try to solve this modulus inequality by using graph. So first we need to do is we sketch the graph of this modulus x minus 2. So first we sketch the graph x minus 2 without modulus. So first this is a straight line going up. So this is y equals x minus 2. Now in order to get the modulus, we need to reflect the part of the graph which is below the x-axis going up. So this part of graph we label as x, negative x minus 2. Then we need to sketch the graph 1 over x. 1 over x is a reciprocal. So which is in the first quadrant and also in the third quadrant. Now we are going to combine these two graphs by using the same axis. So first we draw the x-axis, y-axis, and for the graph y equals 1 over x, then we label the graph. This is y equal 1 over x. Then now for the modulus, this is the part of the modulus that we label as y equals x minus 2. Then the other part of the modulus we label as negative x minus 2 because this is the part of the graph which is reflected. Now from the diagram we can see that there is one intersection point between these two curves. Now we need to find the value of x in this intersection point. So this intersection point is the intersection between the graph y equals x minus 2 and also y equals 1 over x. So when we simplify, we found that it is a quadratic. But when we try to factorize the quadratic, we found that we are not able to. So in order to find the value of x, we use the formula. That is negative b plus and minus b squared minus 4ac and divided by 2a. So when we simplify, we got 2 plus and minus square root of 8 divided by 2. Now, in order to simplify into the simplest form, we found that square root of x we can separate into square root of 4 times square root of 2. And where we know that square root of 4 is equal to 2. Then from here, we can cancel off the 2 here. Then we got 1 plus and minus square root of 2. Since the intersection point is in the first quadrant where x is positive value, so therefore we take x as 1 plus square root of 2. Now we label this point as 1 plus square root of 2. Now when we look at this modulus inequality, since the modulus x minus 2 is greater than 1 over x, means we are going to take the region where modulus x minus 2 is above the graph 1 over x. So when we see this is modulus x minus 2 and this is 1 over x. Now when we look at this region when x is less than 0, so we find that the modulus is always above 1 over x. So in this region, we can say that the modulus x minus 2 is greater than 1 over x when x is less than 0. Now from x greater than 0 up to 1 plus square root of 2, in this region, we found that 1 over x is above the modulus. Means in this region, 1 over x is greater than modulus x minus 2. So this is not the region that we want. Next, when we come to this region, so from here we can see that the modulus x minus 2 is above 1 over x. So means in this region, the modulus x minus 2 is greater than 1 over x. So therefore, we can make conclusion that when modulus x minus 2 is greater than 1 over x, the value of x is less than 0 and greater than 1 plus square root of 2. So therefore, we can write the solution here in set notation where x is less than 0 but not included 0 because 0 is the asymptote. Then another one is x is greater than 1 plus square root of 2 and included the point 1 plus square root of 2 because the inequality is greater than and equal to. Now let's try this modulus inequality. So first, I'm going to take away the modulus sign. So after the modulus sign was taken away, it becomes x power 2 plus x minus 6 greater than negative x plus 3, and at the same time, it is less than positive x plus 3. Now we separate the inequality into two. First one is negative x plus 3 less than x power 2 plus x minus 6. And the second one is x power 2 plus x minus 6 is less than x plus 3. Now we try to solve the first inequality. Now we shift all the terms to the left. Then we try to simplify the expression on the left, and we found that it is a negative quadratic. Now we need to change the negative quadratic to positive. So when we change negative to positive, please remember we need to turn the direction of the arrow becomes greater than 0. Then we do the factorization of the quadratic. Now in order to find the set of value of x, we sketch the U shape. Then because the inequality is greater than, so the set of value of x for this inequality is x is less than negative 3 or x is greater than 1. Now we try to solve the second inequality where we shift all the terms to the left, and then we try to simplify the expression on the left. We found that it is x power 2 minus 9 less than 0. Then we factorize the expression. It is x minus 3 multiplied x plus 3 less than 0. Now when we sketch the graph of this quadratic, we found that it is a U shape, and since the inequality is less than 0, so therefore the set of value of x is x greater than negative 3 and less than positive 3. Now we combine the set of value of x by using the conjunction AND. First, we mark the number on the number line. We start from negative 3, 1, and 3. For the first set of value of x, x is less than negative 3. Then x is greater than 1. For the second, x is between negative 3 up to positive 3. Now because we combine with using AND, so means the final answer for x is where the section of x consists of 2 arrow lines. Therefore, the final answer for this modulus inequality is the value of x where x is greater than 1 and less than 3. Now I'm going to solve this same modulus inequality by using graph. First, I'm going to sketch the graph of this modulus x power 2 plus x minus 6. So first, we draw the x-axis and y-axis. Now before sketching the graph, first I need to factorize the quadratic, which is x plus 3 multiply x minus 2. From this, then I know that the shape is U shape because positive quadratic. From this, I know that the x-intercept is positive 2 and another one is negative 3. And when x is equal to 0, y is negative 6. Now this is the graph of the quadratic without modulus. Now in order to get the modulus of this quadratic function, so for the part of the graph which is below the x-axis need to be reflected up by using x-axis as the line of reflection. Now after the reflection, we found that the curve is reflected up here and the intersect is 6. Now when we label the curve, the part of the curve without reflection, Then we label it as positive x squared plus x minus 6, which is this side and also this side without reflection. Then as the part with reflection, so we label it as negative x squared plus x minus 6. Now we continue to the second graph, that is y equals x plus 3. So this is a linear graph and the gradient is positive going up. So x-intercept is negative 3, y-intercept is 3. So this is y equals x plus 3. Now we need to combine these two graphs in the same diagram. So first, for the quadratic graph, so this is the graph without reflection on the right hand side and left hand side. Then we label this part of the graph as x power 2 plus x minus 6 because this part without reflection. Then as for the part after reflection, then we label this part of the graph as negative x power 2 plus x minus 6. Now we put in the y equals x plus 3. So this is the linear graph, y equals x plus 3. From the diagram, we can see that there are 3 intersection points between the quadratic and the linear. Now we need to find the values of x for this intersection point. So the first intersection point is between y equals x plus 3 and the curve y equals negative x power 2 plus x minus 6. So now we carry out the simultaneous equation. First, we shift all the terms to the left and simplify it. And we found that it is a quadratic x power 2 plus 2x minus 3. Then we factorize the quadratic. It is x plus 3 multiply x minus 1. Then from here, the values of x are negative 3 or positive 1. Now we go to the second intersection point. This point is intersection between the graph y equals x plus 3 and also between the curve y equals x power 2 plus x minus 6. Now we carry out simultaneous equation in order to find the point. After simplifying, it is x power 2 minus 9 equals 0. Then after factorization, becomes x plus 3 multiply x minus 3. Then from here, we found that x is negative 3 or x is positive 3. Now from the diagram, since the x are positive value, so then we know that the first intersection point is 1 and the second intersection point is positive 3. Now when we look at the modulus inequality, since the modulus inequality is modulus x power 2 plus x minus 6 is less than x plus 3, so means we are going to take the section where the curve is below the straight line. Now when we look at this diagram, for this section, the curve is above the straight line. So this is not the section that we are going to take. For the section from negative 3 up to 1, the curve is above the straight line. So this is also not the section that we are going to take. Now for the third section, we found that the straight line is above the curve. So means this is the section that we are going to take as the answer. Then we continue to the last section. So we found that the curve is above the straight line. So means this is not the answer that we are going to take. So finally, we found that the set of value of x that satisfy this modulus inequality is the values of x from 1 to 3. Therefore, we can write the final solution as the set of value of x is x greater than 1 but less than 3.
So, that's all for today. Do you understand what you learned today? Let me know in the comments below. If you find that this video is useful, hit the like button below. Don't forget to subscribe my channel. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye!